Unit circle and graphing. So we're giving this unit circle here, as you can see, we have the degrees, the radians, and we have the exact values, okay? So here's their exact values, here's our radians, and here's our degrees. And the unit circle starts at 0 and goes all the way around to 2 pi. It starts at 0 degrees and goes all the way around to 360 degrees. All right, so you're given the specific question here. The unit circle has been divided into 12 equal arcs. So as we can see, they've been divided into arcs. Corresponding to t values of. So we have these values. We're going to use the xy coordinates in this figure to find the value of tangent pi or state the expression as undefined. Okay, so if I find tangent pi, I know that tangent is going to be sine over cosine, which is also y over x. So if I come and look for pi, what I see here, I got tangent at pi is going to be -1 over 0. Oops, I did it backwards. Did y'all see what I did? It's actually y over x, and I wrote, this is x comma y, which is sine, or excuse me, cosine sine. Okay, so it's actually going to be 0 over -1. Anytime that 0 is in the numerator, my answer will be 0. However, if you get 0 in the denominator, then it's undefined. Okay, and this is always a rule. All right, so now we're given 5 pi 6. Well, let's come find where 5 pi 6 is right here. And we have these exact values. Again, we're going to have to remember that this is y over x. And what is y? It is a half. And x is going to be a negative square root of 3 halves. So now I'm going to rewrite it in a format that's easier to work with. Now be careful on this negative sign. You want to make sure that it doesn't come out as a minus and it looks like a negative. All right, so I'm going to rewrite it and I'm going to apply the rules that you apply whenever you divide fractions. You're going to keep, change, flip. We're going to keep the first term. We're going to change the operation to multiplication, and we're going to flip the second. And I'm going to leave that negative on top here. And we're going to reduce if we can. In this case, we can, because 2 goes into 2 once. Leaves me with 1 times -1 over square root of 3. However, one of the rules is you can't have a root in the denominator, so that means I need to multiply by its conjugate. What's going to undo it? Well, I know that if I take the square root of 3 times the square root of 3, that's going to give me this, which can be rewritten as power over root, which reduces down to 1, leaves me with what's inside. So whatever we do to the bottom, we have to do the top. Now I got -1 times the square root of 3 over 3. So my answer to when tangent of 5 pi 6 is exact form, it's a negative square root of 3 over 3. Okay. Let's try this next one. Again, we know what tangent pi is. It's going to be 0. We just solved that at the beginning. We talked about it. Now I want to know what's tangent at 2 pi. Again, we're back to that where the order pair, the exact value we need to find. And I know at 2 pi here, let me see if I can make this a little big for you so you can see it. At 2 pi here, where the circle ends, it's on the x-axis, so that means y is going to be 0 and x will be 1. So I have now tangent 2 pi. I have 1 over, whoops, let's rewrite it like this. I have 0 over 1, which is 0. So my answer is 0. Okay. So let's go to our next example. We're going to find the coordinates of the given point after it is moved pi 5 units to the left. Well, if I'm moving it to the left, then we're going to the negative values. Okay. If I was moving it to the right, we'd call it the positive. So what does that tell me? This tells me we're going to subtract. This tells me we would add, right? And if we're moving left or right, we're only affecting the x value. So we're going to take it and we're going to minus that pi fifths. Okay. When I do that, I notice that I need a common denominator because we can't subtract fractions without having one. So in this case here, it looks like it's going to be 10. So I need to multiply 2 by 5. And when I do the bottom, I do the top. I need to multiply 5 by 2. And again, what I do to the bottom, I do the top. Now I have 5 pi minus 2 pi over 10. 5 pi minus 2 pi is a 3 pi over 10. And that's my new x value. So whenever we're looking for coordinates given by the points here, after it's moved, since it's moved to the left, it affected the x values. The y value did not change. So here's my answer. Okay, so let's do the next one. Find the coordinates of the given point after it is moved pi thirds units to the right. So that means we're going to add and to the x value. And this here says 5 units upward. So that means we're going to add to the y value. Okay, so let's take it. The order pair that was given. So we got pi for x, and we're going to add pi thirds. Again, we have to have a common denominator, and I noticed that the pi has a 1 underneath it, so I'd multiply top and bottom by 3. This other one, I don't have to make any changes. So I have 3 pi plus pi over 3. 3 pi plus pi is 4 pi over 3. And now let's take our y value. It's a minus 2, and we're adding 5 because we're moving to upward 5. So negative 2 plus 5 is a positive 3. So now my new coordinate is going to be 4 pi thirds, comma 3. All right. Determine the point that lies midway between the two given points. All right. The midpoint, finding it, formula is capital M of x coordinate 1 from coordinate 1 plus x from coordinate 2, all divided by 2. Y from coordinate 1 or order pair 1 plus y from order pair 2. I guess that would be a better way of saying it. So I'm going to label this. This is going to be my x1, y1, and my x2, y2. Okay. So let's just plug in what we know. I got pi plus 6 pi over 2. And I have 2 plus 2 over 2. And let's clean it up. I have pi plus 6 pi is 7 pi. I have 2 plus 2, which is 4 over 2, but that also cleans up again to 2. And that is my midway point between these two order pairs. All right, let's do this one here. So we're going to determine the amplitude, period, phase shift, and the range. So first thing is, as I'm given this function here, and I need to rewrite it. I need to rewrite it where it's y is equal to. Well, we know from basic algebra that f of x or g of x or whatever the function name is, and we set it equal to y, then that means that I can replace f of x with y. And then I have this here, a of cosine, b, let me put a minus here. I was looking at what they had there. Minus my c plus d. All right. So when I look at this, what do I see? I see that my a is -3 and a represents my amplitude. So that means I need to take the absolute value of it. All right. I also see that b has to be written out here. However, if you look, b is just 1. So we don't have to do any extra steps because you wouldn't write 1 here because it's not simplest form. So b is 1, and b goes to the period function. So when I plug in 1 for it, I just get 2 pi for my period. So I know my amplitude, I know my period. Now C represents my phase shift. However, you notice here, the original formula says minus, and what was given is a positive. So in order to make that a minus, I know that negative times negative is a positive, right? So we have to break this apart as negative times that negative pi has. So actually minus that negative pi has. So that's what my phase shift is. Now let's talk about the D. Well, there is no D here. So D is our vertical shift and it's 0 here. So we're not making any changes to that. Now let's find our range. Well, my range is going to be the Y values, right? And what we know is it's going to actually come from my amplitude. So I have a negative of the absolute value of the amplitude, comma, and then the absolute value of the amplitude. So we're going to have the negative and positive of it, and that gives me my range on how everywhere it's going to hit like that, because we are working with cosine here. So it has a sine, or it has a wave looking function. And that is everything. That is my range. So with all this information, we are able to graph it, graph the function.